So here's our second approach, okay, to solve this question. How do we find the speed of the rock, instantaneous speed, at t is equal to 2? Um, this time, instead of choosing a value for h, or the delta t, that we used for my previous clip, okay, we chose delta t to be 0.01 or 0.001, something that was really close to 2, something that's in the proximity of 2. Instead of that, why don't we just leave it as an expression, 2 plus h, or we'll assume h to be a really small value, okay, something that's really close to 0, okay, if not 0 itself, okay. And we're going to use the idea of the difference quotient, f of x plus h minus f of x all over h, along with this function, to see if we could find the instantaneous rate of change algebraically, okay, or we call that analytically, okay, using the algebra of calculus. So let's see. Um, so what I could do is use f of 2 as my f of x, and use f of 2 plus h as my f of x plus h, and h will be that arbitrary value. So write that out, f of 2 plus h minus f of 2 all over h. And what this implies is that 2 plus h becomes our independent value that we substitute in place of t. So that becomes 16 multiplied by 2 plus h to the second power minus 16 multiplied by 2 square all over h. And this expression generalizes the average rate of change. So this particular expression could be the expression that could be used to find the rate of change, the average rate of change for any h value for this particular situation. The h value could be 3, that h value could be 2, that could be 100, or in our case, we want that value to be as small as possible, as close to 0 as possible. Unfortunately, we cannot substitute 0 into this expression for this reason. We have the variable h on the denominator, and that can't be 0 because that would make the whole expression undefined. So we can't quite substitute 0 yet. Okay, we might be able to do that after we simplify. So why don't we try to simplify this algebraically? So let me go to the next page. So we have 16 times 2 plus h squared, which is 2 plus h multiplied by 16 multiplied by 2 plus h times 2 plus h, minus 16 times 2 squared, which is just 4, all over h. And then I would recommend you to multiply 2 plus h by 2 plus h first. But to me, that's easier than to distribute 16 to the first 2 plus h. So if you use the FOIL method or the box method, the area model, whatever method you want to choose to use, you get 4 plus 4h plus h squared. Subtract 64 all over h. And then distribute that 16 in front of the parentheses. So you get 64 plus 64h plus 16h squared minus 64 all over h. And the 64s will cancel out. So you end up with 64h plus 16h squared all over h. And notice, okay, both terms have an h, at least an h. So that could be simplified more by dividing by h. So 64h divided by h is 64. 16h squared divided by h is 16h. And then that, again, that's the simplified equation. This will give you the average rate of change for that function y is equal to 16t squared for any h value, okay? But ideally, we want that h value to be 0 for us to be, to get the instantaneous rate of change at 2, okay? So I guess I should specify that this expression is for finding the average rate of change from 2 to any other point using the depending on what the h value is. But again, we want the h value to be 0, so you could plug in 0 at this time to see what that instantaneous rate of change will be at t equals 2. And when you substitute 0 for h, your final answer will be 64. So 64, let me erase this. So your instantaneous rate of change would be 64 feet per second.